quickly start on the next talk. So just to recap, we had uh, we had already talked about open source and GenAI in observability and a little bit about CNCF and how we are using it for security. The next talk will be expanding more on the security aspect in more detail. We have Prateek and Praveen from PhonePe. They have worked on pen testing and adding it as part of CI/CD and mitigating threats and those kind of things. So I request Prateek and Praveen to kind of expand on their introductions, of course, and as well as talk about the security related open source tooling. Over to you.
Cool. Am I audible? Yes, cool. Okay, so I think, like he said, we are from the security domain. Um, when they actually asked us for a presentation, I was a little skeptical because we are the outliers here. You're all developers. We're still engineers, but you're security engineers. And I was trying to understand how would this topic actually fit to you guys, right? But that's where I actually realized that, I mean, first of all, I'm Praveen, right? Like before I talk about like what I've done in my past, I think I'll talk about the problem statement that I have faced in the past and how can this community help, for the problem statement, right? So, like I said, we are security engineers mostly, right? And then we focus on the main problem of solving for the security, right? And what I've realized over time, security requires very special skill sets, and is very rare, right? And it's also costly. And for organizations to adapt, and specifically for smaller organizations to adapt to security, they might not invest, at least until they get their second or third investment, they will not probably invest in security, right? And you might have very limited resources and you will need to create a security team, right? And even if you created a security team, you will need to automate it, right? And the automation and the tools that are present for security is actually large, but the real problem statement is for organizations to adapt these tools and automate it and use it as part of their, daily life, right? And that's what we are actually going to talk about, right? And with me is Prateek. We both are teammates. So he was just complaining that I'll probably say that he makes me work a lot, but yeah, jokes apart. So we'll be talking about the approaches very specifically, like the assumptions. This is not really a build versus buy talk, right? Are we going to only talk about DevSecOps? Again, no, right? We're going to talk about really the architectures that can actually help for you to automate application security or product security as an organization, right? This is what we're going to talk about. I'll switch to Prateek and he can give a little bit context about what we do and our problem statement.
Yep. Before moving on to arriving at a general architecture of automation framework, I'll just discuss a day in life of a product security engineer. So what we do, we basically protect the org against the adversaries. Those are nothing but your hackers. He talked about the CVs which the open source products have. So similarly, there are vulnerabilities which come in the products which we have developed. We review any feature which goes live for security vulnerabilities. So a single loophole can lead to a data breach. So recently you heard about the Star Health data breach. So though it was not the way loophole in their website, but yeah, there were many. If you go and see into the history, there are many instances where you can see a single loophole can lead to all the data breaches. Then we basically go ahead and do the code reviews. We review the MRs. We do the architecture review. We also do the asset monitoring. Like say for example, you're exposing a new feature, you might go ahead and have a new subdomain for it. So we monitor the assets day to day and see which all assets are being made public. We also care about internal, but more of external, because external is the like an attack surface to any attacker. Then at last, yes, we go on automating the AppSec process, which could make our life easier and so yours. Yep. So before moving on to the crux of the talk today, I'll just discuss a simple life cycle of how our code is being pushed and all. So yeah, obviously the developer goes he pushes the code to some code repository. This can be either GitHub or GitLab. Then obviously, like many organizations follow creating images. Those can be Docker images, which has a simple Docker registry. This can be hosted publicly or internal to the org. Then you have an orchestration platform where basically these images are being sent and the deployment is being done in the cloud DC or the virtual machines. Once all of your applications are deployed, this is how a typical application sort of, you can say, a graph look like. You have an externally exposed asset which goes through a WAF, then which goes through the Nginx, which can be a reverse proxy. Then you have an API gateway. Then you have again an orchestration platform which basically routes your traffic to the downstream microservices. Now, looking onto the this whole flow of a life cycle of a product, we can see where all application security can come into picture. So the first one is in the code repository. So here we have many developers. So can someone answer honestly that has someone pushed a secret actually in prod in GitHub? No? Yes, that's true. So this is like we at the code repository level, we have to basically scan the code for the vulnerabilities. Then we have to do the secret scanning. Then we have to also do the scan for the library scans. As many times the libraries used are sort of deprecated or have vulnerabilities or have CVs in them. Then there's something called as image scanning, where we have to scan the images for the vulnerabilities also. And then maintaining the orchestration security posture and pen testing it, then reviewing the cloud security misconfiguration. Then from the external perspective, you have to do the threat intelligence. What all threats are there in the publicly exposed assets? Are your WAF rules secure enough to block the traffic? Is the API security done right? Are you not exposing the sensitive APIs outside which are meant to be internal? Then obviously these are all internal part of thing where we review the microservices as part of our you can say day-to-day job. Then as we have discussed this, we saw that there are certain scenarios where security is of much importance. So how do we leverage open source to sort of achieve some of these things? So you can find a hell lot of tools for achieving these things. So the first thing is like in the code scan and the secret scan, there are very nice tools, one of which is semgrep, where you can go ahead and write the rules and patterns which can basically go and scan through your code. Then there are some image scanning tools also, like Trivi. Then we have penetration testing tools, which is your burpsuite and zap proxy. Then some of the orchestration security tools, then image scanning tools. Then there are threat intelligence tools. Yeah, I'll just point out to the Mantis over here, because this is one of the threat intelligence sort of framework which we have open sourced recently. Then there is Acto also, which is a runtime API security tool. Yeah. Now we know that, okay, we know that what all to have secure enough, what all to look for in the organization posture. Then we saw there are many tools available for it, but what's the organization adaptability to it? Will the organization accept it? Because many of the tools, if you see, they are catered towards individual pen testers. So why individual pen testers? You would say, are there any individual pen testers? Yes, there are. Companies like they run something called as bug bounty programs, where you find a vulnerability in their system, in their exposed assets, you report it to them responsibly, and they reward you in dollars. So most of the tools the community creates is for these pen testers so that they can utilize it. Then these are, most of the tools are command line tools, and they basically fit into GitHub Actions or the pipelines. But again, GitHub Actions and pipelines, they don't have context. Context, I mean, say for example, I need the data from one tool as part of the another tool. So that's basically you can say short-lived sort of thing, and the results are just pushed somewhere, and they also don't have life cycle management thing. uh, uh, for example, I have a vulnerability which arises in one of my services. I want to manage this end to end, so the next scan should actually go ahead and fix that vulnerability. Yep. Now we saw let's list out what are the missing parts in this. The first one is vulnerability scan. You can say this can be taken care by most of the open source tools. So we can utilize most of the open source tools to perform the vulnerability scanning. Now, other missing parts which are like, say for example, a vulnerability occurs. You need to tag the appropriate developer to fix that vulnerability. Like so, and you need to keep a track of that. Yeah, when was this vulnerability actually detected? So you need to have a issue raising system over there. Then you need to notify the stakeholders when a vulnerability occurs. Then you need to have gating. So say for example, an MR which you are going to merge into the production, it has some vulnerability. So you need to have a process where you should stop this MR from being merged unless and until that vulnerability is fixed. Then you need to auto close this vulnerabilities once fixed. How auto close? Say for example, MR in the MR a vulnerability is detected and you run the scan again. So that vulnerability should be marked as fixed automatically. So with these missing parts, what can we do? We can basically have an automation suite which fits into these, which can accommodate all of these, like our open source tools also and the missing parts. Then on this automation suite, what we can have is we can have an event which basically triggers a scan. Like in case of MR, it's the pull request or the commit can be this, and in case of subdomains it can be a scheduled. So say for example in our org we run our own tool Mantis, which gives an alert to us every morning whether a new subdomain was released the previous day or not. Then you basically need to have scanning on these all components which we saw earlier. So this automation suite, what it needs to have? It needs to have an scan orchestrator. Why scan orchestrator? As discussed, the open source tools are not specific. They are not specific to the product security. So you need to sort of gather all these tools in a workflow, I would say. So you need to run these tools one by one. You cannot sort of link the commands and pipe the output result of one tool to another. So what we can do is we can orchestrate them. For each tool can have a sort of short-lived container. Then comes the gating part where you need to basically have a block on if a vulnerability is detected. Then comes the notification. You should either get a notification on Slack or via email when a vulnerability or something is detected. And then the vulnerability management, which can occur through any of your ticket management system. Yep. Now, now if we see that some of the components from the parts which we discussed are actually common in nature, like vulnerability management, gating, and notify. So this can be added as a shared library to a Lambda layer. We'll go specific with the Lambda in this use case, as many of the organization use AWS. So these can be the events. Say for example, a new merge request is being created. You go ahead and trigger a semgraph function, which is added to the AWS Lambda layer, which is added to the AWS Lambda, which in turn imports these layers. So it does a scan of all of your semgraph rules on this particular merge event and notifies you and raises the vulnerability if it has any. Similarly, it goes with the new image event. You run a trivia function which scans for your image and again manages the vulnerability and notifies you. Then you have a new domain event where you can run Mantis if you have this, and then this basically goes ahead and run the Mantis scan, and it raises vulnerabilities and it also notifies you. So this is the common, you can say, sort of architecture. This AWS Lambda can be replaced by any of your functions. You can have Kubernetes or any other like Azure functions also over here. Yeah. So you can see this is sort of the architecture which we use currently at PhonePe, and this is how we manage the vulnerabilities. We have a scan service, which is our automation suite, which gets the scan, which gets the event when when an event is triggered. It creates a short-lived container for any of the tools, say SemGrep, Trivy, or Mantis, and it runs it, and the results are being pushed to the DB. And once the results are pushed to the DB, a notification is sent. And once the results, if the scan service finds that the results contain a vulnerability, then this vulnerability is given to the vulnerability service, where it does the vulnerability management. It goes to the gating thing, where it puts a block on GitHub if there are any, and it raises a ticket on Jira. Similarly, you can see this is where you can use AWS Fargate or Azure short-lived containers also for this. And we have couple of events, and these events are basically sort of config driven. So you can write a new config on which you want to trigger the event for. Yep. Praveen, you want to?
Okay. So was it a lot like sounded like German or Dutch, or you guys had the context? Yes, little bit. Yes, yeah. So, but what we have actually tried to do is come up with a common solution. Like even you went with commercial tools, for example, you can have a commercial tool to solve DevSecOps, or you can have a commercial tool to solve for image security. Everyone will come up with their own implementation and try to fit into the organization, and then the rollout process, depending upon the size of the organization, can be really large, right? And that's where what we are trying to do is build a common system. No matter what problem you're trying to solve for, if it is going to be event driven, for example, be it you're going to push in a code to GitHub, or you're going to push in an image, or it is going to be creating a policy to your orchestration platform, the the main orchestration platform or the service to handle this will be the same. And then you can fit in an open source tool or a commercial tool, right? And also make sure that the existing open source tools that have been developed for security, again, like I said earlier, these have been developed by security engineers. So they want to solve the crux of finding the security issue and not the engineering side of it. And that's when it becomes difficult for the organizations to adapt it, right? And that's why we've actually built a framework, right? So the first Lambda way that we actually showcased was for anyone to pick up, because that is just based on any event. But we don't pretty much use Lambda in our ecosystem. So we developed an automation suite, which is basically the suite which has both scan service and vulnerability service, which does all of it. And all of them are basically plug and play. We have right now a client for GitLab. We are soon to write a client for GitHub also. And in terms of short-lived containers here, again, like you have the Azure container instances that you can use, but our ecosystem, we have developed our own orchestration platform, which is called Rove, which we recently open sourced last week. And that's the one that powers our entire ecosystem and our transactions, right? It is not very feature rich as like Kubernetes, but it does the basics in a solid way, right? Right. So like I said, one is solving for a common framework to solve the entire automation, but there are use cases. Everything is not direct, right? So in terms of like, a GitHub or GitLab where you receive a merge request, it is just like a one-to-one. Like you trigger a merge request, there is one scan that is run, and then you have a result. But there are cases where you will actually have workflows. For example, we have also built another framework to solve, basically to help organization, any small organization, like any of you're all part of different organization, right? Using Mantis, all you need to do is give your top level domain. It will go understand your subdomains. It will go understand your certificates, open secrets in your organization, public publicly exposed domains, vulnerabilities, everything, right? So this basically requires a workflow. So what we saw was just a simple scan or a trigger for an event. This is basically a workflow. So for example, like I said, you give your top level domain. The first thing the workflow will do is discovery, where it discovers all the subdomains and the IPs, etc. for your organization. And then it will do a recon to understand the different technologies that you use. And once you identified that, then it basically triggers a scan on all your subdomain and assets and actually provides the results in a dashboard, right? So this is a second level of framework every organization will need to solve for. So we basically solve for both, where you have a single event and a single scan, and also where you have workflow, right? So this is a third part. So right now, if you actually see, we have implemented this in an organization, and we have almost an average of 8K commits per day, and then we have schedule scans of around 5K. So both our services use around 4 cores, 4 GB memory, and the total infra we have is around 8 cores, 192 GB to spin up this. So we'll run almost a total scan of around into 3, we run around almost 3 tools per commit. So we have around 25 to 30K scans that we run every day. And the average scan we actually require is around 4 cores, 4 GB memory, right? And then the resource requirement was pretty much one security engineer. And then the skill set required is pretty much anyone who has knowledge about Lambda, or even Python would do to develop a fast API service. And we will soon open source this, and then organizations can simply adapt this and can actually do it, right? Challenges we face, again, very important, right? Most of the tools that we discussed today are not customer facing, except of course, the Gen AI platform. The important part about security is, of course, we can develop the tool, but you guys, developers or engineers, are the one who are actually going to use it. And they'll definitely come back and crib us. There are a lot of false positives, right? So what we took as an approach, for example, let's take SemGrep. SemGrep is a code analyzer, right? It has both an open source edition and a community edition. In the open source edition, it is just single file, right? You have regex patterns, etc. It scans a single file. In a community edition, it can go across multiple files. It can identify source and sink. This is what we call as taint analysis. For example, you have a vulnerability in your HTML page, which basically takes script, right? And the script gets synced in, to your database, for instance, right? So unless you find the source and sink, you will not be able to sure shot say that this is a vulnerability, right? So what we started to do is, instead of focusing on too much true positives, because we definitely know SemGrep open source cannot go and achieve something at this scale. So what we try to do was the reverse. For example, in Android, say a lot of vulnerabilities occurs due to WebView misconfiguration, right? So we actually started to write rules where we could actually identify the entry points of the vulnerabilities, right? And then the other important part is to train your developers and engineering team to understand like how this is all used, and whether whatever you develop makes sense to them, because they are the end users. We are not the end users, right? So that's an important thing. Of course, if you've developed something, you will need to maintain it, right? That's the reason why we want to actually open source it, so that there is also community input from it. And of course, since we use a lot of tools, like we showed a list of tools, these tools needs to be updated on a regular interval. That comes along with everything. Okay, I think almost there. So the open source links, so automation service soon to be open sourced. Mantis we already have. Like I said, if you're a part of an organization, just go and give your, it's a command line tool, go and give your top level domain. It'll give you the entire history of the public assets of an organization. Drove Orchestrator, we just open sourced it last week, and we have the documentation as well. This is the one that powers our entire transaction, entire orchestration. And last, considering you're all engineers, developers, we will need your support because we are security engineers. We are actually having our Hacktoberfest for Mantis. We have raised issues. You can go ahead and contribute to the festival, right? So yeah, that's pretty much it. Cool. Any questions? Yeah.
One aspect is, as you said, in the build side of the things.
Sure.
Since you are going through the scans and all, is there any in the cycle? Are you also certifying the artifact that you're generating so that it can be validated at the runtime when the architecture comes in?
Okay, so you're talking about the deployment part.
So two parts. On the build side, you have scanners, you have SCA, SST, then your vulnerability scanners, BAPT and all.
Correct.
And after that, you are generating artifact, which is an image or any artifact that you are creating.
Correct.
And that is then going to be published as a deployment artifact, correct?
Right.
So at that time also, are you validating that this artifact is generated by our system only, or somebody else have is directly putting in?
Right. So that's kind of a two-part problem statement,
Yeah.
right? So let's go at the code level. The first thing is at the code level, right? Just to ensure that what we validate goes is, because like to any default branch is what we check, and anything that's pushed to the default branch is where we actually add our gating. So without a gating check, you cannot go into the default branch. The second part is the image generation, right? So which is either part of your actions or your pipeline. So you generate an image for that particular aspect, right? The third part is your deployment. Like for our organization, we have a different configuration tool where we actually go ahead and deploy, right? So we have a different system which basically collects the information at various parts, which is your pipeline, the image that was generated, and the image that you're deploying. Of course, we cannot know that this version is required for this upgrade, right? That is something that we cannot calculate, but at least we know that this was a vetted version.
Okay.
Right? That would happen because we have another system that basically tracks all of these records right from your build version, the MR that was published, and then in the pipeline, what was the image that was generated. And in the last, when we go to a configuration editor, it validates that it was a validated pipeline.
Okay. My second question is related to the shift left part of it.
Correct.
Are you doing anything on that side where
this is completely shift left? So
the developer itself in the developer desktop, when they are building, are we doing any scans and
see, there is a limitation there. Like I said, right? Like if you take secret scanning, of course, why would I let a developer push a secret into my GitLab and then I will say that, okay, hey, don't do it,
Yes,
right?
absolutely.
So the reason being is that your repository, like GitHub, your GitHub or GitLab, right? They provide options, but they are not. For example, they have a server level webhook where if you set the webhook, when you do a git commit itself, it will not let you do.
Yeah.
But they have not provided the infrastructure to basically support the scale. So it is an experimental thing, right? So say we set it and then think GitHub or GitLab goes down, that becomes an additional problem statement. That is the reason why we have to go, but that's where we need to achieve, right? But other than that, everything is shift left.
Okay.
So what we have done is you create a feature branch. The moment before you merge it to the actual branch, that's where all of this kicks in.
One question related to the gating side of it.
Sure.
As we are blocking with the gate, for example, we have the checkers, and say it will be the gating criteria will be based upon the CV level.
Correct.
So now, if, for example, I don't want to take anything of critical and high vulnerability, but I allow medium and low for say some of the aspects.
Right.
Now, somebody comes up, it's a dev project, for example, and I allow high vulnerability.
Right.
So those kind of changes, or if you're adding some exceptions, we know that we have done the risk mitigation, it is not going to impact me.
Correct.
So those gating, for example, as you said in the flow, we are creating zero ticket.
Right.
After that, if somebody approves that zero ticket,
Correct.
what happens with that?
We've addressed that also in our service. So what happens is there are two ways, right? If I found a vulnerability, you fixed it in code, you run your pipeline again, it will be marked as fixed automatically. Case number one. The case number two is it's a false positive, or it's something that you plan not to fix. You can go ahead and mark it in Jira, and we have a webhook enabled. It will automatically change the status. Next time when you run the pipeline, it will be considered not to be considered for gating, and it will succeed. That is also something that we've handled.
My last question is to the Mantis.
Sure.
We have this reconciliation process which is more about discovery of the things.
Correct.
Right? So when we typically do a threat modeling, we have this process of defining your architecture design also.
Correct.
So how different it is from that?
See, Mantis is threat modeling is where you evolve your design based on the vulnerabilities you identify.
Yes.
No, Mantis is specifically for the assets that your organizations expose to the internet. So what happens, I'll tell you, I've worked with different organizations of different scale. I worked with an organization where they still don't know all the assets that they have published in the internet because they're so huge. And you might be a startup and you might have exposed. You might still not know. There's no, unless you have a Route 53 or something and use it standard, people will not know, right? With this, if you just give the top level domain, it will identify all the assets from the internet, which are published to your internet. Not just that, it will also identify secrets, vulnerabilities, certificates, everything of that sort. It's a complete workflow automation. So all you need to do is run this command line tool. If you're working for, say, like x.com, you just need to give x.com, and then it will give you the entire history of your internet assets.
Okay.
Yeah, this is something any small organization can simply, time up. So can just start to pick up and get it done. Yeah, cool. Thank you, guys.
Thank you.
Awesome. Thanks, Prateek, and thanks, Praveen.
Yeah.
We'll
Thanks for the great question.